We don't have much time, so let's get into it. The term juggler has evolved significantly in meaning over time. Originally connected with magicians, troubadours, and even charlatans, it wasn't until around 125 years ago that a modern idea of juggling started to emerge, but historical depictions do go as far back as ancient Egypt. In the modern day, we accept that there are many kinds of juggling, from object balancing, gyroscopic juggling, contact juggling, swinging, striking, non-continuous tossing and/or catching, and the focus of today's video, toss juggling. When working to understand toss juggling, you first need to know the variables at play. All toss juggling has to consider timing, height, and trajectory. As you begin to add more numbers to the equation, these variables need to be more and more precise, otherwise collisions and drops are likely to occur. When evolving from beanbags, even more variables enter the fray. With juggling rings, angle now becomes an axis of difficulty, and when moving on to my favorite prop, clubs, rotation becomes yet another. So when all comes together, every single object is operating with 5 degrees of complexity, and that's just for the basic pattern. In the 1980s, several mathematician jugglers started developing a numerical system for expressing possible juggling patterns and tricks. This body of work eventually became what we now call site swap notation. Very basically, it describes the kind of throw being made as it relates to timing, so a higher throw will take longer to be thrown again, and the way this is depicted is based on what quantity of objects would operate at that relative height. The number 5 in a sequence is thrown at a 5-ball height, and the number 7 at a 7-ball height, and so on. Okay, but here's the cool part. Say you want to figure out if a pattern is possible, and you have an idea to throw 1 high and 2 low throws in a 3-throw sequence out of a basic pattern. Let's speculate that the high throw will be represented at a 7-ball height, and the low throws will be thrown at a 4-ball height. In a left-hand, right-hand alternating sequence, we get the pattern 7-4-4. The number of throws in a repeatable sequence is called a period. So, 7-4-4 is a period 3 sequence. Now take the 3 numbers, add them together, and you get 15. Now you divide the sum total of numbers by the period. 15 divided by 3, and you get 5. If doing this process results in a whole number, that tells you how many objects are needed to achieve that pattern. And if you don't, that pattern is not valid. Additionally, a single instance of 7-4-4 may be thrown as a trick out of a basic pattern, but you can also turn a majority of tricks into its own pattern. With this in mind, you can begin to connect tricks into other tricks if you understand the heights that you need to transition into. There's so much more, but the last thing I want to touch on is how you can twist patterns based on throw variation and hand position. A basic 3-ball cascade can turn into a reverse cascade, a crossed arm cascade, or into Mills mess, all while maintaining the throw height, but switching up your hand position relative to the basic pattern. And now my absolute favorite thing to work on is throw variation as it relates to club rotation. For the rest of this video, I'll show you a bunch of variations of the very basic pattern 4-2-3, with a high throw, a pause, and a crossing lower throw. For the purposes of site swap notation, these are all the same pattern, but can look strikingly different from one another. Thank you so much for your time, and I'll see you in the next one.